Hello friends, my name is Fardin. So I have come here to give a easy explanation of redox reaction rule. So let's do in the brief what is the redox reaction rule. So first we will go the big rule or the theoretical rule and the simple and easy format. So first rule is that the atom or molecules which are present in free or uncombined state shows zero oxidation. For example, sodium which is showing oxidation state 0, you take zinc 0, you take nitrogen 0. So the second rule states that in combined state all alkali metal of group 1 shows +1 oxidation state and alkali earth metal of group 2 shows +2 oxidation state. As you can see, NaCl +1, MgCl2 Mg +2 as it is in the group 2. You can see the elements in the group 1 which are present over here, group 2 also shown over here, and in BeCl2 Be from second group +2. Let's move further. So the third rule states that the charge present on monoatomic ion is equal to its oxygen state. Like lithium charge is +1 as you can see, so its oxidation state will be also +1. Sodium +1 oxidation state +1. It's bromium -1. So let's move on further. The fourth rule states that generally oxygen shows -2 oxidation state. What does it mean? Like H2O -2, O, it's generally show O2 -2 oxidation state. But there is an exception. In peroxide, oxygen shows -1 oxidation state, like H2O2, Na2O2 -1. And there is also another exception, like when oxygen atom is directly attached to fluorine, then it shows positive oxidation state. Let's move further. We aren't wasting any time, straight to the point, just go on. The fifth says that like when hydrogen atom is combined to a non-metal, so its oxidation state will be +1, and when a hydrogen atom is attached to metal, the oxidation state will be -1. So here's an example, H2O. As you can see, oxygen is hydrogen attached to oxygen, non-metal, so its oxidation state will be +1. Let's move on. The another example, NaH. So as you can see, hydrogen attached to metal sodium, so its oxidation state will be -1. The sixth rule states that in combined state, halogen atom shows -1 oxidation state. And there is an important point, fluorine always shows -1 oxidation state, always. And the other point is that when halogen atoms like chlorine, bromine or iodine is directly attached to oxygen or fluorine, then it shows positive oxidation state. As you can see, example here, BrO -3. So Br, we have to find the X, plus oxidation state of oxygen is -2. 3 item, X minus 3 minus 2, 3 into -2, -6 equals to -1. So X will be +5. This -1, you might be wondering where does it come from? This charge. So hence it is proved that it always shows positive when attached to oxygen or fluorine, the atoms like chlorine, bromine or iodine. Let's move further. The last table is left. Seventh rule. The algebraic sum of oxidation state of all the atom present in neutral molecule is equal to 0. C6H6 X plus 6N equals to 0. The algebraic sum of oxidation of all the atom present in polyatomic ion is equal to charge present on ion, like BrO3 -1. So it will be equal to the charge present on the oxygen, like -1. And the ninth rule, the last one, oxidation state may be fractional. So this is a very big, so you just can't use every time. Like if you are studying and you need a quick reference, it's not possible. So I have an easy and quick reference point. I've made an easy table for understanding. Like here everything is covered, like elemental form 0, only one kind of atom present, no charge. Atomic ions equal to the charge on the atom, monoatomic ion. The elements of group 1 is also given over here, +1 unless in elemental form. Group 2A elements are also given, plus 2 unless in elemental form, hydrogen plus 1 when bonded to a non-metal, minus 1 when bonded to a metal, and in oxygen minus 1 in peroxide, minus 2 in all other compounds, the most common one. Fluorine, as I told you, minus 1 always. Neutral compounds, the sum of all oxidation numbers of atoms or ions in a neutral compound is 0. And in ionic compounds, the sum of all oxidation numbers of atom is an ionic compound is the charge on the polyatomic ion. So you can take a screenshot of this thing. So I'll tell, this will be very useful for quick reference, as you can stick on the wall or you can stick to the page up on the table, or you can keep it with you as a quick reference. As solving the numericals for oxidation state, you need them, but when you use it number of time you'll remember them, but when you learn first time, this is the most easy and efficient way. So I suggest you to take a screenshot, and or rather I would say make it of your own and stick it on your wall or use it as a quick reference. Thank you.